Joined. Okay, so welcome everyone to the sixth live session for the course Geomorphic Processes, Landforms and Landscapes. It is taken by Professor Javed and Malik and myself, Ananya Mukherjee. I am a PMRF fellow from the Department of Earth Sciences, IIT Kanpur. So till now we studied about fluvial geomorphology and also tectonic geomorphology, the relation, the interaction between the two geomorphological processes. Okay, so we saw how they, interact and then together they can change landforms and landscapes. Now we will move on to the other agents, natural agents, which are shaping the landforms. So today in today's session and today in this week's content also, you have been introduced to two geomorphological processes. One is your glacial and the other one is coastal. So we will first get into the glacial part. So what is glacial geomorphology? Glacial geomorphology is the study that we do to understand the processes, the landscapes and landforms that are produced by movement of ice sheets. Okay, movement, transport, and deposition that is done by ice sheets. They can be, large, large tabular kind of forms, or they could be, forming in the mountains, or in valleys. Okay, we will see the different types of glaciers that are there. Okay, so a large mass of ice collected somewhere, okay, like in thickness as well as spatial extent, those are called glaciers in, common understanding. So when these ice sheets they move on the surface of the earth, okay, so they will kind of drag sediments or drag material with them. Okay, at some places they will disintegrate the rocks that are present over there, and the later on they will deposit the material that they had carried with them. Okay, either on top of the glacier surface or at the bottom of the glacier surface glacier. Okay, so this is the understanding of what we are going to study in glacial geomorphology. Okay, so and with glacial geomorphological processes, we also try to understand the rate of the movement of the ice masses. Okay, how they will erode, and then we can also try to understand glacial retreat and the effects of global warming and other such phenomena on glacier formation and glacial geomorphology. So, now, at present, around 10% of the Earth's surface is covered by ice masses. Okay, and most of the ice masses that we are talking about, they are found, in the polar regions. That is Greenland, Arctic, or in the North Polar region, and Antarctica in the South Polar region. Okay, so these why is it important also for us to learn about glaciers and glacial geomorphology is because the recent effects that we see due to the rising temperatures. Okay, so there is rapid glacial retreat and glacial mass loss is happening. So the mass budget of glaciers is kind of tilting. It's going a bit off balance. Sea levels are also rising because more and more ice is melting from these big ice masses. Earth in itself is, it undergoes glacial periods. Okay, glacial periods as in the time where large areas on the earth are covered by ice, by glaciers, okay, by ice, and they stay frozen for a long period of time. Okay, so these have kind of, climatic implications that they are staying frozen over there, and the period that they stay frozen is longer periods. Okay, so these glacial periods they do happen after every 100 and 150,000 years. Okay, they have happened in the past also. The last one was around like few thousand years ago. Okay, so it's a natural process, as I said before also. All geomorphological processes, they are natural processes. They have occurred before, they are occurring now also. But right now, it's important for us to understand them and try to, mitigate the risk factors, because the risk it has to property and life right now in the current scenario. So that is why understanding how glaciers are moving and what sort of work they are doing. Also, the loss of glaciers is important for us to understand. So as I said before, two of the largest ice masses are seen in Greenland, the North Polar region, and the Antarctic sheets. There are also huge glacial masses that are found in very high mountain ranges, Himalayas for an example. Okay, so those are alpine glaciers. And that is why we are saying that these alpine glaciers are usually, they occur in mountain valleys, cirques, hanging, and Piedmont glaciers. And some also occur as ice caps and ice fields and ice shelves. Okay, so we will see few of these terms like in the coming slides. So before we go into glacier, the geomorphology aspect of it, we will try to understand what are, glacial periods, and how glaciers are forming, and what sort of work do they normally do, with respect to the shaping of landscapes. So presently the distribution is, the two images are present over here. The upper image is the present situation, the present ice coverage or glacial ice coverage. You can see it's over here and the Antarctic area. Okay, but around 18,000 years ago, okay, like it's the recent almost, okay, in the Holocene period itself. Okay, so you can see that a large part of the area was in the northern polar region was covered by ice, and even in Arctic, you can see the amount of the extent of the ice sheets was much more seawards. Okay, so you can see that we had a glacial period around 18,000 years ago. Okay, now the period that we are in is called interglacial period. Okay, usually interglacial periods are warmer periods. So extent of glaciation, as I said, Pleistocene, that covered almost 30% of the continents. Okay, and like around if ocean basins are also considered, okay, then we can consider around 60% of the earth's surface was covered with ice. Now, as I said, that earth, kind of it the cycle, it has a cyclic process of being glacial and interglacial conditions. Okay, and these the period, okay, they last for around 100,000 to 150,000 years. And we, yes, Ice Age is known as the glaciation period. Okay, so we call it Ice Age, considering the duration between which the glacial period, the glaciation was, at its peak. That time is Ice Age. Okay, so we've had multiple ice ages in the past. And when did we start learning about this glacial, interglacial kind of periods is, around 19th century, when sediments which, sorry, I don't know what's wrong with the slide. Yes, Ice Age that we spoke about, the Milankovitch cycles, if you remember, we had talked about, which is factored, the one of the factors that affect those cycles is the precession of the Earth. Okay, so due to the position of the Earth around its rotation axis, and also the change in the rotation axis, the inclination, okay, all these things do affect the climate, and that is why we have these glacial interglacial periods. Okay. Yeah. So, as I said that we found glacial, lithified sediments. Okay, there are some characteristics of those sediments using which they found that, in India also we had the Indian landmass was also part of one of those glacial periods where we found the Talchir boulder beds. Okay. Uh, and this was related to Permian. Sorry, this is not related to Permian. This is in the like the Gondwana time. Okay, so this was I think around Triassic period. Okay, and then Permian glacial sediments were also found in England. Okay, so after finding these sediments and doing studies on them, researchers, started the research on understanding glacial geomorphology in a, more vigorous manner. So the how do we know glacial periods have happened? Okay, there must be some sort of a method which is easier for us to, measure, and we can say, okay, because of this, at this point of time in the geological past, the temperatures were cooler or, they were warmer. So one of the ways that we can do that is by using oxygen isotope ratios. Okay, so it uses oxygen isotope ratios of, O16 and O18. Okay, so O16 is the lighter isotope, whereas O18 is the heavier isotope. Okay, so the ratio of these isotopes change over the time because of the changes in the climatic regimes. Okay, so you can try to take samples from, see, ice, the glaciers in the sense. Okay, so they build up over ages. Okay, so they have not just formed in just like, say 1 year or just few hundred years. They have formed over thousands of years. Okay, so they keep a record. Okay, so the chemical composition of the ice does keep a record of the climatic conditions that were prevalent when they were forming, when that portion of glacier had formed. So if you take the samples from these, okay, these are called ice cores, okay, that kind of drill into the glacier and take out cores. Then you measure the isotope ratio, the oxygen isotope ratio that is, within that ice core. Okay, and it will give you the, indication of what the climate was during that time. Okay, so how do we know what is the mechanism to understand this? So light oxygen, okay, in water, it evaporates faster than O18 in the water. Okay, so if you consider C, okay, there is evaporation happening since O16 water is going to get evaporated faster. Okay, so C inherently is going to be richer in O18. Okay, there will be O18 also getting evaporated, but the quantity is going to be less. Okay, so there is going to be a disbalance. O16 is going to reduce in the water and O18 is going to increase in the seawater. Okay, now both these isotopic water, they are going to form the clouds and there is going to be precipitation, which is going to give you the, increase in glacial mass. So now from precipitation, okay, again over there, when it is getting precipitated, okay, again the what to say, the isotopic ratio is going to differ. Okay, so O18 will be preferentially removed relative to O16 by precipitation. Okay, so again that ratio is going to help you to understand whether the glaciers were, whether there was more evaporation happening or there was less evaporation happening. Okay, so hence we can say if the oceans are relatively rich in O18, okay, glaciers grow and hold the precipitated O16. Okay, so the O16 that is much greater when evaporation is, taking place, when precipitation is happening, okay, when the glaciers are forming, okay. So oceans are usually rich in O18, whereas the glaciers will be more rich in O16. Okay, so this ratio, if you find out, is going to help you to understand at this age of the glacier, this was the climatic, scenario over there. So you can see even in the, the the graph over here, the where you can see the peaks. Okay, the blue peaks where you can see, okay, you can see it is the, negative, that ratio. Okay, and these are the ones when glacial periods, sorry, yeah, these were the time when there was glacial periods. Okay, when the del O18 is, I think, higher. Sorry, yeah, the peaks are actually, where they are, going down. It's the negative is on top. Okay, so this is hotter and this is colder. This is the ratio. Okay, this is not the quantity of O18. This is a ratio. Okay, isotopic ratio. So then, right now, we are living in an interglacial period. Okay, this is a warmer climate that we are in. Okay, there was a glacial period before this interglacial period started. Okay, so this is how, we kind of try to understand how glaciers are, they are a proxy to climatic, regime changes. Now we come to know how glaciers are forming. As I said before, glaciers do not form in just 1 year or, or just 100 of years. They take lots and lots of years. Okay, so first the precipitation happens in the form of snow. Okay, then when the snow is, kind of, with time, it will keep getting compressed. Okay, as compression happens, the air between the snowflakes is going to, it's going to reduce the spaces, the pore spaces that if you say, okay, they are going to reduce between the snow, and then snow will turn into granular ice. Okay, then the granular ice is going to, get compressed, and due to the compression, it's going to recrystallize. Okay, recrystallize and become much, much compact, which then develops into a fern. Okay, then the fern together will get compressed and they will, crystallize into larger glacial ice masses. Okay, there is air, but though that air is now trapped. Okay, so it is not in void spaces between the, fern grains. Okay, now it's they are going to get trapped as bubbles in the glacial ice. Okay, so uh, and these are not just, at polar regions only. Okay, so there are other regions also where you can find. Yes, Kuldeep. Yes, uh, I said that global warming is actually a natural process. Glaciation, interglacial periods are also natural process, but the rate at which the global temperatures are rising, okay, that is affecting us. That is why it is of concern. Okay, so Earth has experienced much, much warmer climates before also. Okay, but we were not there. And also we know that a lot of extinctions have also happened, okay, due to sudden such, processes. Okay, so that is why, it all of these processes are natural, but the rate at which they are happening right now is much different and it affects us. So as I was saying, glaciers also form in different, sorts of scenarios, environments like where mean annual temperatures are close to freezing point. Okay, winter precipitation produces significant accumulations of snow, and temperature throughout the year is like not a result of the complete loss of previous year's snow accumulation. Okay, so these places can also form glaciers. Okay. So now we understood how glaciers formed, okay, glacial periods, and now once glaciers have formed, okay, so they usually the, places where you have the thickest accumulation of the snow and the ice, okay, that place might not, move. Okay, that place is kind of, perennial in nature. Okay, it's always going to be there. But the edges of the glaciers, okay, those are the places where you will find glacial movement. Okay, they are not just, small sections. They are like, thousands of kilometers of sheets can also move. Okay, so when these glacier sheets or these parts of the glaciers they move, okay, so these are the ones that cause erosion, they cause transportation, and then when these glaciers kind of melt, okay, and they are no more they are no more traveling forward, okay, so they are going to deposit the material that they eroded and transported. Okay, so the glacier movement can, there are few mechanisms how they happen. The one is basal slip erosion. Okay, so the basal slip happens is when the, plane between the bedrock and the glacier bottom. Okay, so, there could be abrasive particles, okay, that is being dragged by the ice. Okay, so this could be one of the reason why the glacier sheets are, kind of just slipping along a bedrock, okay? And the most important part is that they are lubricated by liquid water. Okay, so you might think it's, the entire thickness, through the entire thickness of glacier, it's going to be, frozen. But because of pressure, okay, because of pressure, the part where there is contact between the glacier and the bedrock, okay, it's lubricated with water, and because of that, the glaciers are moving, okay, so that is called basal slip. So during the basal slip, some part of the bedrock would be, it could be broken by movement, and they are going to travel with the glaciers. Also, they can, striations along the bedrock. You can see in the second photo over here. Okay, so there are striations. It's because of the abrasive rock material that is, traveling with the glacier downwards. Okay. Another way how glaciers move and then the way they erode is called plucking. Okay, so plucking is that due to glacial erosion, okay, so sometimes a lot of bigger rock fragments are kind of plucked out of a place, okay, or where the glacier kind of meets an obstruction. Okay, suppose the glacier is moving this side. Okay, so this is up ice side, okay, and this is the down ice side. Okay, so the glacier was moving, so it was moving from here, okay, over here, kind of a stress regime is created, and it is going to pluck these rocks, okay, these particles, these rock fragments, and it's going to drag it with them. Okay, so this phenomena is called plucking. You can see there are, this is this abrasions are also, you can find that in both basal slip kind of a movement as well as plucking movement. Okay, and you can see these kind of yeah, rocher mountaineering. Okay, so these are erosional landforms that are created by the glacier movements. These are called roche mountaineering. Okay, so now we know that erosion is something that happens when the glaciers are moving, along bedrocks. Now, what sort of sediment transport takes place? Okay, so there are a few things that affect the glacial erosion. Okay, obviously, thickness of ice is going to be one of the important, factors. You have whether the rock is the bedrock is softer or harder. That means whether it's resistant to erosion or not. Then your basal ice temperature, also the gradient of the slope along which the glacier ice is moving, what sort, how much basal sediments are present, the debris, okay, the rock fragments that are being carried by the glaciers. the velocity of the glacier, and also how jointed the bedrock is. If there are a lot of joints, okay, if, where the glaciers are moving, it's easier for erosion processes that are done by the glaciers. So now erosion has happened, a lot of material has, kind of, it's being carried forward by the glaciers. So there are three kinds of, transport based on the layers, okay, supraglacial, englacial and subglacial. So supraglacial are the debris or, sediment material that is transported on the glacier surface. Okay, and usually this just is, whether suppose the glacier is moving down a valley, okay, when it's moving down the valley, there are, valley sides or cliffs, okay, so maybe because the top part, okay, is not supported enough by the lower, the eroded slopes, so it might fall, okay, it might fall on the glacier and then it will get carried forward by the glaciers. Okay, so these are supraglacial, that is on the surface. Then you have englacial. Okay, so these are debris that are carried from the bed along the flow lines. Okay, or supraglacials that get buried because of more and more snow accumulation. Okay, and later on they will, they can re-emerge at the ice surface in the ablation zone. We'll see what is the, ablation zone after this. Okay, and subglacial is the debris that is transported, beneath the glacier. Okay, so these are the debris that, are there at the bottom of the glaciers. Okay, these are mostly the ones that are picked up by the, disintegration of the rock, of the bedrock. Okay, and these get embedded in the ice and then they are carried forward. So the sediments that are transported will also, they will help in erosional action of glaciers as well as the depositional action of the glaciers. So, the glacial ice, okay, it is just not going to move, as just, the way it is. Like, it's just not going to move if you just, how if you take a slope, okay, you have a slide, okay, so you suppose you just put one block on the slide and it just moves down, okay, there is a hold, okay, there is frictional forces that are acting between the glacier and the bedrock. Okay, and also all the ice in the glaciers is not moving at the same rate. Okay, so you can see it over here, like if you take from the top part, okay, uh, if your bottom part is lubricated with water, okay, it's easier for it to flow in a uniform, almost uniform manner. Okay, but if you have a frozen bed, okay, like this, the contact between the glacier and the bedrock is not lubricated with water, okay, so you can see that the top part of the glacier is going to move much faster than the bottom part of it. Okay, you can see the top part is moving faster than the bottom part. And in the glacier with wet bed, you can see that, it's almost uniform. Okay, there is deformation plus slip, and for glaciers which have frozen bed, you have mostly deformation. Okay, this deformation is that you can see that the top part of the glaciers, okay, most of the crevices are formed. So the top part of the glaciers is kind of, the brittle zone, and it's few meters, okay, and the rest of the part, okay, it's actually following the plastic flow. So this is called the zone of plastic flow. Okay, and the top part over here is actually the brittle part. Okay, so you can see that these formation of, these joints kind of a thing on the ice, okay, these are called crevices. So that is why we say that when glaciers have frozen beds, the flow is from the internal deformation. Okay, this crevices also, they will start, flowing because of this deformation. With wet bed, it's going to be both deformation as well as sliding uh, along the bedrock. Okay, so this is also, the kind of difference between the movement of the glacier based on whether the bottom is, the wet based or dry based. Now we come to types of glaciers. Okay, so types of glaciers, mostly there are two important types. First one is the continental glaciers and the other one is alpine glaciers. Continental glaciers they cover, huge area. Okay, so as I said, Greenland and Antarctica, they are examples of continental glaciers, and mostly these areas are, they remain cool. Okay, they remain cold over large periods of time, or obviously because of their location also. That is bound to happen because they are situated at the polar, at polar locations. Alpine glaciers, they also are, called as valley glaciers. So these usually form at very high elevated mountains. Okay, the high elevation mountains, and these occur in both temperate and polar regions. And usually the flow that is associated with the alpine glaciers is due to the gravity. Okay, in continental glaciers, if you have read news or if you've ever seen videos, okay, you can see that they usually start cracking, okay, from top, and then they break off. Okay, for continental glaciers, usually deformation is the kind of the most dominant way of glaciers moving, or glaciers kind of retreat, glaciers kind of moving and breaking off. Okay, deformation. But in alpine, usually you will see that they move due to gravity because they have steep gradients. Okay, so alpine glaciers usually move along slopes, so you will mostly see uh, gravity kind of acting on it, as well as as we discussed before, you will see basal slips over there. You will have deformation as well, but you will have slip also associated with them. So for alpine glaciers, you have, kind of two very, you know, different zones. There is one zone which is zone of accumulation, there is zone of ablation. Okay, so zone of accumulation is usually at the higher elevations and zone of ablation is much lower. And there is a point, okay, the line that is dividing the zone of ablation and zone of accumulation is called the equilibrium line. So even understanding the equilibrium line behavior is going to help you get an idea whether the glacial is growing or if it's retreating. Okay, so if the equilibrium line is kind of, moving towards the top part, okay, so you know that the ablation zone is also moving back. Okay, so that means the glaciers is retreating. Okay, so if the equilibrium line is, going lower towards the ablation zone, and the ablation zone is also, hence kind of growing towards the land, you can see that the glaciers are growing. Okay, so obviously the accumulation zone is where you have precipitation, and the ablation zone is where you have the melting of the glaciers. You can see over here, this is an example of continental glacier. You will find even these have a lot of, erosional and depositional landforms. Okay, and you can see that Greenland and Antarctica, these are, kind of satellite images. Okay, and over here you can see that there is a red line over here. Okay, so this is your equilibrium line. Okay, so this part is your accumulation zone and this part is your ablation zone. Okay, over here in the diagram also you can see that this is the accumulation zone. Okay, and this part is your ablation zone. This is accumulation, this is ablation. Okay, and there are different kind of landforms which are associated with these. There is another type of glacier that is called Piedmont Glacier. Okay, so this is the glaciers have formed. Okay, and they are traveling down the mountains and they spill out onto a flat foreland. Okay, and this area it remains in the cold, cold weather, cold temperatures, and the glacier keeps, forming over there also, then it is a Piedmont glacier. So now we try to see, what is the life cycle of glaciers, okay? Like we had in, you know, uh, rivers also, you had youth, you had mature, and then you had old, okay? So similarly, if you just consider this, okay, and these are kind of the factors also, there are a lot of factors which affect or which, govern the formation and the melting of glaciers. Okay, so snow accumulation happens in the center in the high elevated areas, okay, and the glacier is moving, okay, so you have ablation zones and you have ice shelf carving. Okay, this is what happens mostly in, with respect to continental glaciers, where, in Antarctica, where the glaciers are meeting oceans or sea. Okay, so a lot of, ice shelf carving happens over there. Then you have sea ice also. Okay, and albedo. Usually, albedo is high in, glacial regions. Also, if we are in glacial period, the total albedo that is, given by the total albedo of the earth is going to increase, okay, because more land mass is covered by ice, so you will have higher albedo, okay. So as you can see, this is like, this is going to take 10 to 100,000 years, okay, this entire accumulation. And you will also have subglacial lakes. Okay, we will learn more about these different, landforms in the coming slides. Okay, so this is kind of like, your entire cryosphere, cycle, how uh, everything is interacting with the formation and the melting of the glaciers. And over here you can see this is just like a profile along a glacier. Okay, so you have uh, you know, uh, first snow on the snow, and then you have fern, and then this is your glacial ice. Okay, and you can see that there are, these crevices that are there, and you have the accumulation zone, ablation zone. This is your point of equilibrium line. Okay, so this is where you have melt water and rain, and over here you have sliding and you have strain. Okay, so as I said, you will even glaciers have a cycle of erosion, okay, which is similar to how fluvial cycle of erosion also happens. So at youth stage, okay, so you will have more cutting activity or, higher erosive activity by the glaciers. Okay, in mature stage, you are going to have, kind of broader valleys, broader, glacial glacier structure. Okay, so where it is flowing in the mature stage. Okay, and also there is also going to be erosional activity, but there are some depositional features also that are present over during the mature stage. In the old age, mostly you will find very wide U-shaped valleys. Okay, and you will have outwash plains. Okay, these outwash plains are going to have different kinds of depositional landforms. And after that old age, usually what happens during the old age is like the uh, you know uh, two different glaciers can merge at one place, okay, and then together they will flow ahead. Okay, so these are the characteristics, different characteristics for the different stages of the glacial erosion. So now we come to the glacial erosion landforms. Okay, so usually the landforms that are created in the erosional stage of the glaciers, they are very, irregular, and they have sharp edges. Okay, and usually these form at, the high level, high elevated areas. Slides are taking some time to load over here. Okay, so you have, the first landform, erosional landform that we are going to talk about are cories or cirques. Okay, so where accumulation has happened. Okay, so when that accumulation happens and this, the ice, the glacier starts moving down slope. Okay, these are in alpine regions. Okay, so they are going to form depressions. Okay, due to the weight of the glaciers, and it is moving downwards, it's going to pluck the bedrocks. Okay, and it is going to create depressions, and this is where more and more accumulation keeps happening. Okay, so these will get deeper with active plucking and abrasion processes, and it's going to form a circular bowl shaped depression that is called a cirque or corrie. Okay, these are usually the accumulation zones of for alpine glaciers. Okay, and later on you will see that you know sometimes the once you go down the cirque or the corrie. Okay, there are some areas where you will have the ice melting. Okay, and the water gets collected over there. Okay, that is called a corrie lake or tarn. Then you have horns. Okay, what are horns? Horns are like pyramidal peaks that are formed by kind of two cirques kind of eroding. Okay, there are two cirques here. Okay, this is your cirque one, this is your cirque two. Okay, with erosion. Okay, these are going to this area is going to get eroded, and slowly later on you'll see that a kind of sharp pyramidal peak is forming over here. Okay, so suppose there are three cirques over here. Okay, so, C1, C2, C3. Okay, so when all of these are eroding, okay, so the ridge, okay, the kind of rock area that is dividing these cirques. Okay, so they are getting eroded, and then later on you're only left with the peak over there. And suppose there are there is one cirque here and one cirque here. Okay, and between these two cirques there is a just an elongated or a a kind of a linear ridge that you can see. This is called an arete. Over here you can see that this is a arete. Okay, so there is cirques here. Over here you can see that if these start eroding, you will form an arete over here, and because of all three cirques eroding here, this will form a horn later on. Okay, so there is a horn already forming, and this is an arete, and this is a tarn lake. Okay, so suppose because the glaciers have moved below. Okay, and some ice was left and it melted over here, so it formed the tarn. Okay, there is another kind of a landform, that is Paternoster Lake. Okay, so these are the series of lakes that are formed, that they are being connected by a single stream, and usually they are formed in like depression areas only. Then you have U-shaped glacial troughs and ribbon lakes. Okay, okay. So in U-shaped glacial troughs and ribbon lakes, when the glaciers are moving down, okay, in their down, they will, a lot of other cirques are going to feed the glacier. Okay, so suppose you consider there is a cirque here. Okay, there is a cirque here, and this is one glacier that is coming down. Okay, so this cirque is also going to feed this glacier. This cirque is also going to feed the glacier. Okay, and because of this there is a lot of erosion. Okay, that is happening, and slowly these areas are going to get joined together, and you are going to get a trough. Okay, you can see over here there was kind of uh, you know some glacier was coming from here, some here, some here. Okay, these three are kind of cirques that are giving. Over here also this cirque melted and came from here, the glacial input was from here, this input was from here. Okay, So all these glaciers, and this was the trough that got formed. Okay, you can see it's a U-shaped trough. Okay, and wherever you can see that such valleys are there which are giving the input. The glacier input was over here from this cirque. Okay, so these are called hanging valleys. Okay, and you usually sometimes see when it's when the ice water has melted, you can also find waterfalls in such hanging valleys. Okay, these are also called tributary valleys. Okay, this is the main glacier. Okay, the movement where the movement was happening, and these are all tributary valleys which are giving input to the glacial ice. And there are few other erosional landforms also. There are something called coals. Okay, where two cirque basins on opposite sides of the mountain erode the arete also that are dividing them, and then they form a bigger depression called a col. Okay, so suppose there was this horn, maybe this was the arete before, okay, which got eroded away, and now there is one single col. Okay, so there will be cirque 1 and cirque 2 together, they are forming col. Okay, you have another landform that is called a ford. Okay, so this is usually that happens at the glacial trough, okay, that is coming. It is drowned by sea, and you can see that the glaciers is kind of interacting with the sea over there, but there is also fresh water from the glaciers. There is input. Okay, so ford lakes are something that do form because of interaction between the glaciers and the seawater. So now we come to the glacial depositional landforms. Okay, so yes, fjords of Norway are most, they are very majestic in nature. If anytime you have a chance, please do go visit, and they are very famous. So glacial depositional landforms. Okay, before they get deposited, we will try to understand what are the material that is brought by the glaciers. Okay, so you have boulder clay or glacial till. Till is usually the term we use for sediments that are brought by glaciers. Okay, so these are unsorted in nature. So you will find all sorts of sediment sizes in the glacial till. Okay, and you have everything from boulders to clay to silt and fine rock flour also. Rock flour as in very fine rock particles. Okay, you have erratics also. These are boulders, of they are that got transported by the moving ice, and they were left stranded wherever they got deposited. You can understand these are erratics because they will differ from the material that is found in that region where they are being found now. Okay, so they are actually characteristic of some other place through which the glacier has passed. Okay, it carried it from there. So it is usually of a different composition than the area where you are, where you are seeing them. Then you have moraines. Okay, so moraines are usually, the sediments that are brought by the glaciers. Okay, so these form usually when the glaciers are, melting at, when they are flowing down. A lot of the material that is carried by them is mm, they shift towards the sides of the glaciers. Okay, so you can see that when the glaciers are moving down, okay, so they are going to erode the valley walls, okay, and the material that is being transported by them is carried along the edges of the glaciers itself. Okay, so at one place where suppose in the ablation zone, or where the melting is happening faster. Okay, so these material that is being carried down at the edges of the glaciers, it's going to get deposited. These are called lateral moraines. Okay, so these are on the sides of the glacier. Okay, and then when there are two glaciers, they're meeting at a place. Okay, so their inside lateral moraines will join together and form medial moraines. Okay, so over here you can see that this is one lateral moraine from this glacier, okay, glacier 1, and this is your glacier 2, and the inside lateral moraine of these, okay, so they are joining together and they are forming this medial moraine. Okay, you have ground moraine. Okay, what are ground moraine? Ground moraine are rock fragments that are dragged along, okay, beneath the ice sheets, and they are deposited when the ice melts, or and the it spreads on the floor of the valley. Okay, so these are ground moraines. You can see that the ice must have come till here, then it started melting. Okay, or over here, then it started melting. Okay, so these are ground moraines. Then you have terminal moraine. Terminal moraine is, at the end of the glacier. Okay, some we call the end of the glacier as a snout. Okay, so the glacier eventually melts. Okay, it is the the last point where the glacier was till there. Okay, and then it melted, and the deposition that happens along that snout of that glacier is called the terminal moraine. Okay, and then you have recessional moraines. What are recessional moraines? Okay, uh, it could happen in maybe glacier was kind of melting, but then it stopped melting. Okay, then it kind of moved back, and so these are called recessional moraines. Okay, so that is what the deposition of end moraines could be in succeeding waves, and the ice may melt back by stages. Okay, so it can be in a step by step form. So these are called recessional moraines if we are counting from the end moraine. Okay, and you can see this is the outwash. Okay, so you can see streams are kind of uh, running through the moraines, and then this is where all the finer particles would get deposited as outwash plains. There are some other depositional landforms also which are associated with glaciers. So you can see these at a quite larger areas, okay, areas coverage, and you will find all different sorts of glacial landforms, okay, in that place. So over here you can see drumlins. Okay, so drumlins, they are also called as when they occur together in groups, they are called buckets, egg baskets, sorry. Okay, and usually the drumlins are kind of this shaped. Okay, and this denotes the the elongated part of the drumlins will indicate the direction of the glacial movement. Okay, so up ice part is shorter, and the down ice part is longer. Okay, so these are oval shaped, you can see over here, and usually they are they are of the because of the material that is carried beneath the ice sheet. Okay, so they, as I said, which part is stronger? See, these kind of get deposited together and compacted. So in a way, all these are not very strong. Okay, these are depositional landforms. These are not rock outcrops. Okay, so these are any which way softer than suppose you find that Roche Mountain. Okay, so but I think because I'm not sure which part will be stronger. But since the sediment amount is more over here, okay, so if yes, Roche Mountain is usually it's not a depositional feature, it's erosional feature. Okay, so if you are just considering without any action of the glaciers happening anymore on the Roche Mountain or the drumlins, okay, so the Roche Mountain is a single outcrop. Okay, so it is harder compared to a drumlin which is composed of sediments being consolidated. Okay, so if you think about in that sense, then you have eskers. Okay, eskers are these kind of sinuous ridges. Okay, these are also depositional landforms, and these also have the glacial material like sand and gravel. This happens when the melt water is kind of it's flowing through the outwash plains. Okay, outwash plains, as I said before, it's the fluvio-glacial deposits. From the terminal moraines, they are brought down by the streams of the meltwater. Then you have kettle lakes. Kettle lakes are, depressions that are formed due to the deposition uh, that is taking place in the form of alternating ridges. Okay, so suppose there are these ridges that are formed due to the melt waters that are going through the rock area over here. So there are ridges, and between the ridges you will find small depressions where water the maybe either water came and got collected over there, or maybe ice was there, it got melted. Then you have cames, which are small rounded hillocks. Okay, so they are small hills, okay, that are formed. These are also again deposits of sediments. Okay, they are not rock outcrops which are shaped like hills. So these are all depositional landforms that are happen because of glacial action. So now we come to the coastal geomorphology. Okay, so we learnt glaciers. Okay, that is the start of, or you can say the origin of the fluvial systems. Okay, so we have learnt fluvial systems also. Now we go down towards the coastal areas. So most of the coastal geomorphology that happens, it's actually due to the wave action. Okay, and there are some places where you have the interaction between the river systems and the ocean or sea. So coastal geomorphology is the study of the development and evolution of the coast, okay, under the influence of winds, waves, currents, and sea level changes. So why do we learn about this is because mostly, as you know, coastal, landforms are prone to erosion. Okay, so at some places the erosion is much more than the deposition. So these areas are, shifting, the sea is shifting landwards, and at some areas the deposition rate is much more. Okay, but as we know, if the sea level keeps rising, the areas which were, where suppose you have beaches, you have depositional coastal landforms, they will get submerged. Okay, so the coast is going to reduce, or it's going to move landwards. Okay, so that is why it's important for us to understand coastal geomorphology also. Another thing that coastal geomorphology is also affected by natural disasters like tsunamis. Okay, we will see how sometimes, what are the effects, what are some of the effects that we see when tsunami strikes a coast. Okay, so as I said before, the coastal landforms are usually mostly due to the result of action of waves. Okay, and these, most of the landforms associated with coastal geomorphology would be erosional because, wave action is much more prominent over there. And wherever you have lower wave energy, you will find depositional landforms. Okay, so beaches are formed where the sandy beaches are usually where your wave action is not very active, okay, or they are low. And if you go to some rocky beaches, okay, so this is the place where the wave action is going to be much vigorous, and there will be more erosion happening in those areas. So before we go into the, kind of what landforms are being created, we will first try to understand how the waves are, traveling, which as a result, causes the erosion and the deposition with respect to the coastal geomorphology. Okay, so waves have potential energy, okay, and because of the position and because of the motion of the water, it also develops a kinetic energy. And mostly the waves are a result of a frictional action between the winds and the water surface or ocean surface. So if the wind speed is higher, the longer distances it can, because of the frictional effect, it's going to carry more water, and eventually you're going to have more wave action of those places, at those places. You can see over here, okay, so as and when it reaches the shore, the wavelength reduces, okay, and the amplitude of waves are increasing, and the wavelength is decreasing than what it was over here. Okay, so usually the deeper water has, circular kind of a motion, okay. So the motion of the water particles is circular, then it becomes elliptical, and then by the time it reaches the shore, it becomes almost linear. Okay, and this is the reason this, kind of changes in the path of the water particles. You can see that the wave action is different. Sorry, the wave action is taking place. Okay, and the wave energy is moving towards the beach. And the place where the waves break is called the surf zone. Okay, so this is the manner how water is being, how waves are forming and how the waves are, kind of what is the transition of the waves from the deep water part to the shore. Based on the wave, okay, wave pattern, wave action, we can deduce some of the coastal processes that take place. So shallow water processes, what is shallow water? Like, towards the shore area, you have shoaling, refraction, diffraction, reflection, and breaking. Okay, so in the bottom part, you can see that, there is refraction, happening. Okay, there is reflection and refraction from the shoreline over here. You can see that the surf zone, okay, there is a transfer of momentum. This is where your waves crash. Okay, so there is a intense wave energy is in the surf zone area. Okay, this area is the shallow water where you can see there is a refraction of the waves and there is energy loss. Okay, and this is the near shore area. Okay, so the waves are propagating in this area. Okay, and this is the area where there is waves are being generated because of the frictional action of the winds. Okay, there is another, kind of coastal process, the wave process. Okay, there is diffraction. Diffraction usually happens at, the wave crests. See, they are breaking over here. Okay, they were coming like this. Because of this, kind of a landform, it's breaking, and you can see that now the waves have, the crest of the waves have kind of curved. And as I said, you can have breakers, waves breaking, okay, near the surf zone area. Uh, it is usually based on the kind of, gradient that is there on the, on the shore. Okay, so if you have flat bottom, you have spilling breaker. If you have steep bottom, you have plunging breaker. And you have very steep bottom, you will have surging breaker. Okay, so you can see the kind of, this wave action is much, much more than this wave action because of the difference in the wave breaking processes. Now there are few currents which are associated with the, kind of erosional and the depositional action of the wave. You have something as near shore currents. Okay, in the near shore zone, you can have long shore currents, cross shore currents, rip currents, and undertow. Over here, we are going to see, you can see the long shore current. Okay, so this is the wave direction. Okay, it is at an angle to the, the beach or the shore, and you can see that the current is kind of, it is along the shore. Okay, it is not perpendicular to the shore, and it is not totally parallel. It is, kind of along. Okay, it curves at, it curves due to its wave pattern itself, and you can see that the movement of the sand is a, direct effect of these long shore current. So you can see the sand over here is going to get transferred over here, then sand over here is going to get transferred over here. This is also called as longshore drift. Okay, and this usually happens in the surf zone area. There is another drift, that is littoral drift. Okay, so it refers to the movement of the sand grains in the direction of the longshore current. Okay, it can be thought of as a river of sand moving parallel to the shore. And then you have beach drift. Okay, this is due to the swash and backswash movement, of the sand and gravel along this, surf zone, this breaking zone. Okay, surf break zone, if you can call it. Okay, and then over here you can see this is a longshore drift in uh, sand dunes. Yes, I will come to sand dunes later on. Sand dunes is a part of depositional coastal landform. Also, it is not, it's more of an interaction between the deposition as well as the, wind action. Okay, I will come to the formation of sand dunes. Another thing that affects the coastal landform formation is are the tides. Okay, so you have coastal, you have high tides and you have low tides. You know that you every day we have two types of tides, and the changes or the occurrence of the tides is periodic in nature. We know one of the most important factors that plays that that kind of gives the tides is the gravitational attraction of the moon. Okay, so you can have different kind of tides. You have diurnal tides, you have semi-diurnal, and you have mixed tides. So diurnal tides is usually, the tide period. The tide period is equivalent to tide day. Okay, you will have one high tide, and then you have a low tide, and then again a high tide. Okay, so the time between two high tides. Okay, so that is your tidal day. In semi-diurnal tide, okay, so you will have three high tides and two tides, and the tide period is lower, smaller than the tidal day. Okay, and then you have mixed tide. Okay, so you will have maybe two high tides. Okay, and two high tides or the two low tides will not be of the same amplitude. Okay, or the same kind of intense. Okay, so you have a lower high tide and you have a higher low tide, as well as the normal high tide and low tide. Okay, so these are the different tides that you have, and you also have tidal range. Okay, that is the with respect to distance. Okay, so that is microtidal, mesotidal, macrotidal. Okay, so the kind of difference between the tidal levels. So these also affect the coastal, processes, coastal erosion that happens. So what are the, factors that are affecting the tides, the formation of tides is obviously the tilt of the Earth's axis and the moon's orbit and the sun's gravity, or the position of the sun with respect to the moon. Okay, so if sun and moon and earth are aligned in either, new moon position or full moon position, we get spring tides. Okay, so these are very high tides. Okay, and if you in a perpendicular position at the moon and the earth and the sun, they are not aligned but they are like in a right angle position, so you will have neap tides. Okay, and normally, as you said, the if at one place you are having a high tide, you will usually have a low tide on the other side with respect to the moon's position. Now we come to the distinction of the different zones with respect to coasts. Okay, so dunes, as Kuldeep asked, dunes usually form at the backside. Okay, it's not usually in the areas where there is active action of water. Okay, so the coastal zone is it's behind the coast. Okay, towards the land, the where dunes are being formed. So what are coastal zones? It is defined as a transition zone where the land meets water. Okay, so this area, this from here till say here is your entire coastal zone. Okay, then what is the coast? Coast is the strip of land. It can be as wide as possible. Okay, that extends from the coastline inland as far as the first major change in topography. So where you will first find the kind of gradient change in the slope of the area, that part is called the coast. Okay, so this entire part is the coast. Okay, from here you can see, then this part is the beach. Okay, so cliffs, frontal dunes. Okay, these are part of the and the vegetation line, that is these this is part of the coast. Okay, coast which is mostly towards the land side. Okay, then you have shore. So shore extends from the low water line to the normal landward limit of storm wave effects. Okay, and you will have two zones over here. One is the back shore and the foreshore. We will get into how the storm profile and the that looks in the later slides. Then you have shore face. Shore face is the seaward dipping zone that extends from the low water line offshore to the beginning of the continental shelf. Okay, so over here you can see this is the beach, that is the shore part. Okay, you have back shore, you have foreshore. Okay, this is your shoreline over here. Okay, and this is a surf zone. This is where your waves are breaking mostly. Okay, then you have the continental shelf. Okay, so this part is usually, the deeper part is the continental shelf part. Okay, so this is the shallow seafloor that broadens, that borders. Okay, so this is kind of the border of continents. Okay, and from there you are going to go into the abyssal plain part. Okay, that is different. So it is from the toe of the shore face to the shelf break where the steeply inclined continental slope begins. Okay, so if there is another inclination over here, okay, so this is going to be your, the continental slope. Okay, so this is the region where coastal landforms are usually, taking effect. Now we come to beach profile. Okay, so you can see that this is suppose a longitudinal profile. Okay, there is a summer profile and then there is a winter profile. Why do we have a summer profile and the winter profile? Okay, so usually, during winter season, okay, the wind speed is greater. Okay, so if the wind speed is greater, the waves are going to have it is going to have more energy. Okay, and it is going to erode. Okay, so during winter beach, you can see that your berm has eroded over here. Okay, berm is kind of a depositional landform only, and you can see the dunes are behind the berm. Okay, as I said before, dunes are usually formed towards the landward side. Okay, and in summer there is going to be more deposition, whereas in winter time there is going to be more erosion. So the first thing that will get eroded is this berm part. Okay, so this will get eroded, and some part of the dune will also get eroded, and the water levels are usually high. Okay, so this is a beach profile with respect to the changes in the season. Now we come to coastal landforms. We saw how the waves are propagated, what are the different kinds of currents that are associated with the wave action. We also saw what effect the different seasons might have or the tides might have. Okay, so usually landforms are formed due to the action, the corrosion, abrasion, hydraulic action, solution, and attrition. Okay, that is caused by the waves. Okay, you can have erosion as well as deposition. Some of the erosional features are cliffs, notches, caves, then you have arches, okay, and for depositional features, you mostly, beaches, pits, okay, these are depositional landforms that are, made by the coastal geomorphological processes. So first we come to the erosional landforms. Okay, so the most, common landform that most know of about is the are the cliffs. Okay, so these are steep. Okay, these are almost 90 degrees. Okay, rock faces, and usually, obviously, they are vertical or they are very steeply inclined. Yes, Kuldeep, you have a question?
Yeah, ma'am, I wanna ask you from the previous slide,
Yeah, wait. Previous slide, which one?
uh, the previous one, yeah, ma'am, this one, the deposition and erosion during winter and summer.
Oh, okay, yeah.
So, ma'am, why there is deposition during summer? Is that because of the pressure gradient force that carries the wind
Yes,
through?
actually, the wind is not that strong in the summer. Okay, it's gentler. There is going to be erosion, but the depositional part or the depositional action is a bit more. And that is why the you can see the height, the elevation is kind of increasing, or it's there. The depositional features are there.
So, what is the source of the deposition?
Source of the deposition is the sand, the material that is being brought in by the waves, or as we spoke about those longshore currents where sand is migrating from one place to the another.
Okay, ma'am.
Okay. Okay, so cliffs are usually, how they form, the process or the, journey of it is first, usually one crack opens up somewhere. Okay, then it keeps growing into a cave due to hydraulic action and abrasion. Okay, these are usually at places where, mostly rocky beaches or areas where there are, a lot the land mass is there. Okay, there is land over there. Okay, maybe not many rivers also around that area, so you can understand, these things, these landforms will be a part of rocky beaches. Okay, then the caves become bigger, and then when the caves are, kind of, it's the headland area is kind of a tip kind, it's, the tip is towards the sea. Okay, this is the sea. And due to the wave action, okay, this area gets keeps getting eroded. The place beneath this top part, okay, beneath this rock mass. When this keeps getting eroded, okay, so this area kind of collapses. Okay, this forms an arch first, then with increasing wave action, okay, so this area also gets eroded, and then it cannot hold on to the weight of the top part or the roof of the arch, okay, so it will collapse, and then you will get a cliff over here. Similarly, over here, there's a cliff, there was an arch over here before, and the rock collapsed maybe. Okay, also there over here the rock stack then gets eroded from here, and then again this part will again fall and it can form a stump. Okay, so this is the way cliffs are generated, and also the other erosional landforms are generated due to the wave action. You can see over here there is something also called cliff retreat. Okay, this area is getting eroded, okay, because of the tidal action and the wave action. This is also called a wave cut notch. Okay, a notch is any, small opening or a small, uh, you can say a crack that has developed. Okay, so these, because of the wave action, okay, there are some joints and planes of weakness also that are formed. So due to ongoing action, erosive action over here. Okay, so this part will get weakened and this will fall, and the cliff face will move towards the land. So this is known as the retreat of the cliff retreat. And and now what you can call this is the wave cut platform. Okay, it's like a platform, and it is made by the wave action of by the wave action and the reduction of the retreat of the cliff face. Now, how headlands are usually formed? Okay, these headlands, as I said, rocky areas, or where you will mostly get land, high elevated lands are also present over there. So, if this area is hard and this area is made up of softer material, maybe you can say there is a river flowing from here and this area has only sand silt. Okay, as we know, at the end stage of the river, it is only going to deposit finer particles, so this is going to be soft. Okay, so this area will get eroded, and this area uh, this area will get eroded. Okay, and it is going to form these curved kind of a things. Okay, and this area will have deposition over here. It will get eroded, and it will this area will get eroded faster than this. Okay, I'll just erase this and okay. Okay, so this area is harder to erode. Okay, so this will form a curve like this, and this area will get easily eroded. So all the material from here goes, into the sea. So that is why you have headlands forming where the hard rocks are there, and you have bays. Okay, how you also know, in we have Bay of Bengal. You can see that Bay of Bengal is usually like this. So this is your headland, this tip is your headland, and this is the bay. Okay, so this part is bay. You know why? Because we have your uh, delta due to Ganga, then you have the Mahanadi Delta. Okay, a lot of rivers are forming deltas in this area. So this area is weak. This area is made up of softer material. So this place is going to get eroded with time. Okay, and this place is going to stay the same because this is the kind of the margins that are present, and these are mostly made up of harder rocks in that sense. Okay, so that is how headlands and bays are created by, again, coastal erosion action. As I mentioned before, first you get one, notch, or you get a crack, then with more and more time and action, the wave action, the place will start getting eroded and you will start forming waves, the caves, then arches, then stacks, and then a stump. Okay, so it's a process. So we learned how wave action is forming the erosional landforms. Okay, now we will try to see how the depositional landforms are also created by the wave action. Okay, so usually the sediments that are, getting deposited because of coastal action, it could be brought in by the, say, by the waves itself, or it is just transporting the material from one place to another. Okay, spits are an example where it happens because of the change. See, Bay of Bengal is the if you see the way it is forming, how, yeah, it is, obviously it is, but I'm trying to make you understand how it actually, you know, how even that area is called a bay, because it is surrounded by land on the three sides. Okay, and it is a similar kind of the what you say, the top view of it, it's a similar pattern. if you consider headlands and if you consider bays. That is why, it's an example mostly in the sense how it might happen. In Bay Area, okay, in Bay of Bengal also, most of the deltas are actually kind of formed in the bay, in the coastal region that is encompassing the Bay of Bengal. Okay, that is why I chose that as an example to make you understand how it will, how kind of it is there. Yeah. Also, initially, India, you can say, is not just, it was not only in that form also, okay? It's because of the erosional and the kind of, tectonic activities that it has come to that shape, okay? A bay is something that is surrounded by, uh, land on three sides. And that is why you can say that part is, there is wave action even going on now. As you know, the shoreline keeps changing over there. So, as I was saying, so spits are usually formed due to the, they are like long ridges and they get elongated and curved due to change in the direction of the coastlines or the wave energy that is there. Okay. It could also be a mouth to the estuary. Okay, of an estuary. Estuary is a place where I had mentioned before also where rivers are interacting with the sea water. Okay, so this is your bay, okay? First it was, just an elongated ridge over here and with changing in the, longshore current or the, say the energy of the wave, increases or decreases. Okay, so this will start curving. Okay, the sand from here is getting moved to the next place. Okay, now there are sometimes, there is a place behind the spits, okay, where the water kind of gets collected and remains stagnant. So it will kind of create a marshland. So those are called salt marshes. And you also have another depositional landform, elongated kind of, they are similar to spits, but spits, as I said, the edge of it or one end of spit is going to be like a curve kind of a feature, and bars is going to be elongated depositions of sand, and usually they are created by longshore currents. Okay, and obviously they are also going to help in creation of bays. Over here you can see that this bar is there and then there is this bar. Okay, so there is a bay over here. And if there are if the sediments are getting collected at one place near a bar, okay, so bar will get extended, okay, extended towards the sea, and it will maybe it will join an island somewhere. Suppose there is an island over here, okay, and the bar that is being created over here is joining the shore and the island, okay, so this is called a tombolo. Okay, so this is again, tombolo is also a depositional landform. Now we come to dunes. Okay, so usually they are forming on like flatter beach profiles. There is a lot of sediment supply to the backshore part of the beach. Okay, so these are a bit different as I said before also. Dunes are not totally formed by wave action. Okay, so it is due to the interaction of marine processes and the wind or the atmosphere. Okay, and dunes are kind of necessary for coastal environment is because these kind of help in mitigating the risk that is there due to tsunami occurrences. So if dunes are vegetated, then the dunes are going to be more stable. If the dunes are not vegetated, okay, so erosion will take place much faster, and it will be an unstable place, and it will also be affected very drastically during tsunamis. Okay, so as before also I explained, berm during calm summer weather, okay, usually the beach grows, okay, there is more deposition if there is calmer wave action, okay, and the you know more and more sand will get deposited in this berm area, okay, this place, okay, because of swash action, okay. So sediments are being deposited, okay, then again due to swash action, some part of it is getting, taken back to the shore. So that is why there is deposition also, but you will see that this deposition has a very steep face. So the beach face is very steep. Okay, so this kind of a feature is called a berm. Berm will, if the berm is, growing in size, you can say that, it's not a very stormy area. If the berms are getting eroded and, the between dune and, beach face, there is not much, there is no, not many berms present, then you can say that area is, getting affected by storm kind of weather over there. Then we come to marine terraces. Okay, so marine terraces are mostly, kind of erosional landform, but these, kind of give you an idea whether that place has, undergone any tectonic uplift or a sea fall, sea level fall. Okay, so the higher terrains are actually the older marine terraces, and the lower one where the uh, say your shore is over here, okay, right now, so this is your older terrace, and then now there is terrace over here also. This is being formed, okay, so this is during time 1 and now it is time 2. So this is the present place. And sometimes maybe, some terrace must might have formed, when there was a, you know regression of the sea, okay, and sometimes older terraces can get submerged also because of sea level rise. Okay, so terraces and kind of, dating them with respect to sediments, with respect to the lithology that is present, you can say whether that area has undergone, how many times sea fall rise and sea level fall. Okay, sea level rise and sea level fall. Okay, so this is an example from Santa Cruz Island. Now we saw that, how sea level rise and sea level fall is going to kind of, you can see it with marine terraces, and you can also understand that by studying paleo shorelines. Okay, so paleo shorelines is, kind of, usually their shorelines are linear features. Okay, so if you sometimes see a satellite image, okay, and you do further analysis, you can actually point out the different, older shorelines that were present before. Okay, you can see the linear features, and you know that again it could be, due to sea level rise also and sea level fall also. During sea level rise, the older shorelines might get, submerged, and then later on due to, sea level fall, you will again see the re-emergence of these shorelines. Okay, so there are different scenarios where you can have, older shorelines being either seen or they are getting submerged. Okay. Then we come to something that we had spoken about when I was talking about deltas. You have lagoons and estuaries. Okay, so a lagoon is a body of water. Okay, that is, you see them along the coast. Okay, and it is separated by the ocean or sea, but it has inlets. Okay, it has inlets, and it has inlets through which you can see that this, uh, water, the lagoon water can still interact with the sea. Okay, so lagoon usually has, it could be, it is mostly salt water. Okay, and there could be some input from the freshwater rivers also into the lagoon. Okay, but that is not necessary. As you know, Chilika is one of those lagoons where you have freshwater input as well as the seawater input. I think Chilika is called a freshwater lagoon. Okay, so the input, it's a very unique ecosystem that Chilika lagoon has. Okay, whereas an estuary is an area where a freshwater river or stream is meeting the ocean. Okay, and usually the salty water is mixing with the fresh water, and that area has brackish water. Okay, we call brackish water is water that is salty, but it is not as salty as the ocean. Okay, so this area, okay, this is like the estuary part. Okay, again, this is also separated from the ocean by a sand spit. Okay, but there is an input of the river. Okay, this is an interaction between the river water and the ocean water. In lagoon, the ocean water only gets separated from the main ocean, okay, by the existence of such coastal depositional landforms. Okay, so the main difference between lagoon and estuary is the flow dynamics. Okay, estuaries, the water flow is fast and strong, while lagoons have more stagnant and shallower, water. And estuaries are usually deeper than lagoons also, because over here, over here, the interaction between the ocean and the river water is much more in estuary. Okay. Then we come to another depositional feature, that is the barrier islands. Okay, so these are formed due to repeated wave action, and the sediments are traveling, parallel to the shoreline. And because of the shifting due to the weather and the, local, local lithology or geological features, these islands kind of also keep moving. Okay, and sometimes they can even disappear when they get submerged due to the rise in the sea level, and they are separated from the mainland, okay, by tidal creeks, bays and lagoons. Okay, so suppose you know first this was connected, okay, as a one bar, okay, one sand bar. Then with change in direction of wind as well as the change in the direction of the current over here, this part might get eroded. As you see now, the spit is also, it is turning inside. Okay, so this part got, either submerged or kind of eroded. So you're just left with this isolated bar. So this is a barrier island. Now we come to the, another important aspect of coastal geomorphology is the effects of tsunami. Okay, so tsunami is something that affects the coastal areas in very drastic manner whenever they occur. Okay, so firstly, understanding how tsunami is formed, okay, due to tectonic movement, okay, plate movement, a rupture. Okay, because of that, the water above that area, it starts getting displaced from that place. Okay, so due to that, you see that there is a buildup of the, energy because of the quake. Okay, and then it travels. So, and usually the wavelengths of the tsunami waves, they continue to grow. Okay, and then when it approaches the shore, okay, so since the depth from the water surface and the land, the bottom of the sea, okay, since that decreases, the amplitude of the waves start increasing. Okay, and when it breaks, so it reaches a very, very high amplitude, a very high, the height of the waves are too large. Okay, and then you have the impact. Okay, so when the waves break, they cover a large area, landwards from the coast. Okay, and then they cause a destruction. So this is in general how tsunamis, how they start and how they build up and then they approach. Okay, So one of the most important or one of the most disastrous tsunamis that we've seen is the December 2004 tsunami that was caused due to the near the Sumatra and Andaman region. Okay, as I had, I think, explained this before also, it was because of two kinds of faulting happening at one place. So you had interplay thrust faulting as well as strike faulting. Okay, and because of that, that in the entire region next to Sumatra and also the Indian coast, the eastern, Indian coast, and Sri Lanka, these all these places, they faced the effects of the tsunami. You can see over here how the tsunami waves traveled. Okay, and 200 meters per second. Okay, and the rupture, it kind of to the rate or the velocity or the speed of the rupture was 2.5 kilometer per second. Okay, and it was northwards. So you can see that this is how the tsunami waves got generated, and then they traveled and kind of dispersed along the around the areas. So you can see in the image now. Okay, this was before the tsunami occurred. Okay, so this is March 2004. You can see that there is a kind of a construction over here. In June 2005, you can see that only a tip of it is visible. Everything after that is submerged. Okay, so tsunami kind of, it causes land subsidence. Okay, the place where it suppose down thrusts. Okay, the area when it's faulting. Okay, so one of the rock blocks, they went down. If you remember, we had spoken about the normal faulting and thrust faulting or reverse faulting. Okay, so for thrust, your kind of hanging wall went on top and footwall went down. Okay, so the area which went down, that is going to experience subsidence. So all the coastal regions that was, on that down thrusted block, they experience subsidence. So you can see that you can only see the top part of it and everything else is now submerged. Okay. Over here also you can see that because of the 2004 tsunami, you can see that this area got submerged, but you can still see the area. Okay, but after 6 months, you can see that there is no, you cannot see any part of any land of it. Okay, and you cannot make out. You will, it looks like that this was always submerged. Okay, this is due to the subsidence that takes place due to the effect of tsunamis. Okay, now there is a way we can study past tsunamis in one area. Okay, some areas are prone to tsunamis. Okay, so how do we understand the intensity or the recurrence level of it? So there is you can do that study using corals, the growth of the corals. Okay, and also the destruction that is there on the corals, rotation of the corals. Okay, these are some of the aspects of the corals that you can use to study past tsunami occurrences. Okay, so this is an example. So usually the corals that are used for this study are called porites. Okay, so usually their growth is hemispherically outwards. Okay, when it is in the water. Whenever it intersects the water level, okay, it stops growing above the water and it will start growing on the sides. You can see over here it is growing on the sides. Okay, now once it was growing on the side, okay, if the islands sink due to subsidence due to the tsunami that has occurred, you can see that now the part which was growing sideways now starts growing upwards. Okay, this could be seen in areas which subsided due to the tsunami that occurred, and in the place where it suppose the land was uplifted, okay, due to the displacement on top, or as we said, if the hanging wall has gone on top in terms of a thrust fault, okay. So it was growing upwards like this over here, okay, but now the sea level has fallen, okay. So now all this part, the top part is not going to show any growth, and now the coral is going to grow sideways. Okay, so the structure of the coal, the growth lines that you see in the coral, okay, so in such corals, you can get an idea about whether this place was subsided or it was uplifted due to the effects of tsunami occurrence in the past, or right after the tsunami has occurred also. If you want to study the area, you can study the corals over there if they are found, and you can understand the land subsidence and land uplift that has happened over there. Okay, so this is the end of the glacial and the coastal geomorphology. For the next week, I think we have the aeolian geomorphology, that is due to the wind. Okay, so if you have any questions for today's content, you can ask right now.
Um, uh, I have a question, but this is not related to this week's lecture, maybe week 7. I have a question which is related to week 6. Can I
Okay,
ask it right now?
yes, yes, sure. Go ahead.
Okay, there is some sort of confusion with me, which is like in terms of the gradient and the sinuosity of the channel. Normally,
Okay.
it was shown in the week 6 lecture that as the gradient reduces, there was a experiment done by the Schum which says that if the gradient reduces,
Hmm.
then sinuosity also reduces, right? And as the
Okay.
gradient increases, the sinuosity increases.
Yes.
But on the contrary, if we see that the sinuosity of the river or meandering of the river is maximum in the plains region,
Hmm.
not in the uplands region, so this is some sort of contradictory statements. So which of them is correct?
Okay. Also, I think what will play a role is the sediment supply and the sediment size.
That's
Okay.
absolutely fine. That's absolutely fine. But there is a distinct relationship which I even wrote it down in the week 6. It says that as the slope increases, sinuosity increases. But we know that once the river comes from the highland regions to the plains region,
Hmm.
actual sinuosity starts there. Meandering starts there. You
Yes.
do not find meandering in the rivers in the upslope region. So these
Yes.
kind of statements, there is some sort of confusion with me regarding that. So that is the one point which is still with me, and this is not cleared so far.
Okay. I'll just open the Schum's classification.
Mm-hmm. You can see the lecture which is there, like there is a relationship between the slope and the sinuosity. Maybe in the same slide you have one and two slide after this. Yeah, this
This.
one which is in the, yeah, which is in the bottom
Yes.
left corner.
Yeah. Bottom left corner. Yes.
Mm-hmm.
Uh, Sinuosity increases
Mm-hmm.
with the slope
Yeah,
percent.
which is normally
Yes,
do not,
what
we
you're
do not
saying
see that,
is
right?
contradictory, yes.
Yeah,
Sinuosity is not, as I said, it's not just the relation with the slope. Okay. When rivers are meandering, okay, when they start meandering, one part of it is getting, eroded and the other part gets deposited. Okay,
yeah,
sometimes because of the deposition and the erosional effects also, okay, the river kind of changes its meandering pattern. You
that's
will
fine.
see in between meandering patterns also, it will suddenly start flowing in a straight line.
Mm-hmm. That's
That
fine.
is again that
That's
it's
fine.
a balance between both the things.
Yeah, I understand. There are a lot of
Yeah.
factors at play. There are a lot of factors with respect to
Mm-hmm.
the sediment supply, with respect to the slope, with respect to the lithology,
Yes.
right? With respect to the resistance of
Hmm.
the overbank things, with respect to
Yes.
the meanders. Fine. But having
Yes.
said that, if I see a relationship between these two things, and in which it is categorically mentioned that as the slope increases, the sinuosity increases, which
Hmm.
is something does not go down well, in which it is a very common sense kind of thing, like as the river come to the plains area, the meandering increases, which in turn is actually the measure of the sinuosity of the river. So
Yes.
this is some sort of confusion with me. Still, it's not resolved. I have searched in another in internet also, but I still find the contradicting statements, right?
Yes, I
So there is a
also
confusion
think
there.
because sinuosity also, it's a kind of a ratio. Okay, so it also depends the sections that you're taking. So suppose your section is pretty large, okay, and the meandering is also happening over there. So sinuosity ratio also depends on, uh, you know, uh, kind of your user related values that you're taking. So sinuosity is a, I think, comparative study. It gives you a more kind of an easier way to understand how the interrelation between the sediments and the slope gradient is taking place.
Uh,
If I
maybe.
find anything more on the, this sinuosity relation with the slope,
Mm-hmm.
if I find it,
Mm-hmm.
we will have kind of a revision class also, okay,
Mm-hmm.
before the exams. So
Mm-hmm.
I will try to see if I can find some matter on this and try to
Mm-hmm.
clear this confusion. Because
Yeah.
now when you put it forth, even I am having those, kind of a bit. I can understand your doubt in in this respect.
Yes. And there is one more which I'm not able to remember as of now. Maybe in the
Okay,
next class I can ask that.
okay,
Mm-hmm.
sure, sure,
And there are a
no
couple more
issues.
probably I will have in the revision class or something. There are a few confusions with me which are in fact contradictory.
Okay,
So I'll ask those. So this was something which I remember. So I asked you. We will wait
yes,
for the explanation on this. Okay.
okay, sure. I'll try to look into this and I'll give you the explanation, hopefully in the revision session itself.
Okay.
Okay, thank you so much, Saurabh, for your question. Yes.
Mm-hmm.
Anybody else has any doubts regarding this week's or the previous week's lectures? So I can, look into it. Yes, Kuldeep.
Not actually about these classes,
Okay.
but ma'am, I actually wanna show you something. Um,
Okay, you can share your screen if you want.
but before that, I think the question he asked, I think that is because in hilly region there are big rocks like boulders and
Mm-hmm.
cobbles that causes the sinuous. I mean
The
that
straight,
meanders.
it's no, it's
No,
mostly
it's not
straight.
that. It's not that. Because of the slope, the channel does not find meanders and it goes in a straight line. Probably the lithology is also very resistive to the meander, so that's why it
Hmm.
goes into the straight line. But once it comes to the plane surface where the slope is not that high, then probably the river starts to meander and the overbanks or the surrounding regions of the channel are not so resistive. So probably they also get eroded, and that's why there is a pattern which develops with the river. So on one side there is an erosion, on the other side there is a deposition. So that's a different thing. So there is a reason why in the mountain region the meanders do not form, and there is a reason why in the plains region meanders form.
Hmm.
So yeah, so there is a reason for that.
And ma'am, one
Yes.
more thing is how it feels like to get graduated from IITs.
Uh, okay. Obviously, it's a very fulfilling feeling when you are graduating from an IIT. So, but I would say that it depends on what you are going to do as a graduate from an IIT. Okay, so either you pursue higher and better quality research, uh, you take that IIT tag and go into it, or you do something which kind of gives back to the society right after you graduate. So it mostly depends on what you're doing after you graduate from such a place. It's not just about being a graduate from an IIT. A lot of us are graduating from IITs, but I would say not all of us are doing work that is fulfilling us. So it feels good, but it also goes down in the line like what you're doing with it. So yeah, I'm glad that even after being a graduate from IIT and now pursuing my PhD in IIT, I'm getting this opportunity to interact with, students who are learning the subject that is very close to my heart. So, and I can give my 2 cents on it and try to, hopefully gain more, you can gain more interest in this subject because of that. So I think that is more fulfilling right now for me.
So, ma'am, you are interested in earth science from childhood.
Not childhood, I would say, from like I started geology from 11th standard in Xavier's Mumbai, St. Xavier's College Mumbai. So I have been studying geology or earth sciences in that manner from that time. Yes. So any other questions or queries that you have, you can ask now, or
Ma'am, you can turn off the recording.
okay.
Then.